So in previous math classes, you have discovered ways of solving right triangles, and by solving I mean finding all of the angles and all of the side lengths of that triangle. And you've used Pythagorean theorem and trig functions, or SOHCAHTOA as it's also known. So this is going to be the second video of how to find or how to solve triangles that are non-right triangles. So just like with the law of cosines, yes, these will work for right triangles, but it's a lot easier to use Pythagorean theorem and those other trig functions. So let's go ahead and take a look at one version of the law of sines. So one version is the sine of capital A divided by lowercase a. So this is the angle, and this is the side length that is opposite, is equal to sine of some other angle and its opposite side, which is also equal to the sine of the third angle divided by its side. So I'm going to go ahead and just real quick write that a little bit bigger to make sure that I know the difference between a capital C and a lowercase c. So it's not pretty, but I know the difference. So this is just one way of writing it. Another common way that you might see it is all of the side lengths in the numerator. So if you do the reciprocal of all that stuff in the top, you'll end up with this formula, which is just as correct. There's no way of saying one is more correct than the other. So either one of these types of formulas will work. The only thing is you need to make sure that you don't mix them. So if you decide to put the trig function in the top for one, you cannot say that the trig function is in the denominator for another. This does not work, and you will get incorrect answers. You need to make sure to always keep the trig function in the numerator or always keep the trig function in the denominator. So here's an example of a practice problem. Strongly suggest you guys take a moment to pause the video and draw this out on your page so you can follow along with me. So hopefully you've gone ahead and paused it and drawn that triangle. But let's go ahead and take a look at what we have. So I personally know that I'm going to use law of sine on this problem because I see what I like to call a side angle pair. So here's an angle, and here is the side that's opposite of it. And we can see that on this example triangle that I've drawn out here. We have been given capital A, we've been given capital B, and we've been given lowercase b. Because we were given that side angle pair, I know that I'm allowed to use law of sines. And that's just kind of like my little hint that I know. So I'm going to start by writing down the law of sines with my side angle pair. Sine of the angle divided by the side is equal to, and at this point I need to decide what I'm solving for. So I don't really have that much information about C just yet, lowercase or capital. But as I look up here, I see half of what I need. I see capital A, but I don't see lowercase a. So I'm going to go ahead and solve for lowercase a since I know the angle that's opposite of it. So this is all I have to write out. I'm not going to worry about capital C just yet or lowercase c just yet. And the reason that I'm allowed to do this is because I know B is given. Capital B is given, lowercase b is given, capital A is given, and that means lowercase a is my unknown. Because I know everything in here except for my unknown, I can do a little bit of algebra and solve for that unknown. And in this case, I'm really lucky because I'm allowed to cross multiply. You're allowed to cross multiply when you have fraction equals a fraction. If there was anything else off to the side over here, then I would not be allowed to cross multiply. But since it's totally fraction equal fraction, I'm allowed to cross multiply. So I'm going to go ahead and write the denominator of one times the numerator of another equals the denominator of one times the numerator of the other. And again, because my object is to get the variable by itself, I'm going to go ahead and divide both sides by the sine of b and get that side length a is equal to b sine of capital A divided by the sine of capital B. A little bit of substitution and it's off to the calculator. So 16 times the sine of capital A, which is 35 degrees, divided by the sine of capital B, which is 70 degrees. And because I'm hitting those sine, cosine, tangent buttons, I need to make sure that my calculator is in the proper mode. So in this case, the proper mode is degrees because that's 35 degrees and 70 degrees. When I plug it all in, I end up with 9.766. And I'm going to go ahead and round to 3 decimal places. But if I ever need to use a again, I'm going to use all those decimal places that they give me. The more you use rounded answers, the more rounded your numbers will become. So 9.766. And I'm going to go ahead and clean up my picture a little bit by erasing those. So now I have most of it filled out. I've just got these last 2. And at first glance, some people are thinking, oh, let's use law of cosines to solve it. Other people are saying, oh, let's use law of sines to solve for it. You are allowed to use law of cosines to solve for this if you know what that is, and you're more than welcome to finish out the problem as is. But really, there's an easier way to solve for capital C. If we remember that the sum of all interior angles of a triangle is 180 degrees, it becomes really quite easy to solve for capital C. 180 degrees minus A minus B equals C. 180 minus 35 minus 70, which means that our angle C is 75 degrees. So with just a little bit of algebra and a little bit of thought, we can quickly determine that our angle is 75 degrees. Now again, in sakes of practice, I would strongly suggest using law of cosines to solve for it. You cannot use law of sines to solve for this angle just yet, but you could use law of cosines to solve for little c, and then use another method to solve for your big capital C. But if you haven't learned law of cosines, don't worry about it. So let's go ahead and use law of sines and calculate that last c value. I'm going to go ahead and use my same side angle pair that I started with for 2 reasons. 1, 16 looks a lot nicer than 9.766, and 2, I prefer to use what's given over what I've calculated. If I can avoid it, I try not to use anything that I've ever calculated because I may have made a mistake. I'm not perfect, I make mistakes sometimes. So sine of capital B divided by B equals sine of capital C divided by little c. Because it's a fraction equals a fraction, I'm allowed to cross multiply. C, excuse me, that looks like a capital C. C sine of B equals B sine of C. To get lowercase c by itself, I divide both sides by the sine of capital B. So B sine of C divided by the sine of capital B. Last but not least, a little bit of plugging in substitution. 16 times the sine of capital C, 75 degrees, divided by the sine of 70 degrees. And we'll go ahead and plug that in. 16 times the sine of 75 divided by the sine of 70 gives me 16.447. We'll go ahead and round just a little bit there. 16.447 is that last side length. Now the very, very super last thing I want to do is double and triple check to make sure that my answer makes sense. Because of the ratio of these side lengths, I know that the smallest angle has to be given to the smallest side. So the smallest angle is 35 degrees, so the smallest side does go right there. 9.766 is in fact the smallest side. Largest angle is 75 degrees, and that does get the largest side. Medium angle does get the medium side. So we're on the right track here. At this point, I probably should have pointed it out earlier, but this triangle is not drawn to scale. It's simply a reference for us, just so that we kind of get the idea of what's C, what's B, what do I know, what don't I know. So let's go ahead and take a look at one more practice problem here. And in this case, they did not give us a sample triangle, so we're just going to go ahead and draw our own here. Just draw any old triangle we want. And I'm going to put a little note to myself that says not to scale. I never expect my students to draw any of their triangles to scale. Because labeling is arbitrary, I can choose to label it however I want. Now, I do need to say that they gave you D, E, and F, so your triangle should say D, E, and F. But what doesn't matter is where you put D, E, or F. Very important, though, we've got capital and lowercase letters that are across from each other. Little f has to be opposite of big F, and little e has to be opposite of big E. So we'll go ahead and fill in what we know here. We know that little e is 10, we know that little d is 13, and we know that capital D is 55 degrees. So this is simply for my reference. Some people need to draw out the reference triangle, some people don't. One thing that I do see pointed out here that is awesome is I start with a side angle pair. So that's how I know that I'm probably going to use law of sines here. If I ever see a side angle pair, I'm going to jump straight to that law of sines. So let's go ahead and do that. I know that the sine of capital D divided by lowercase d is equal to, and the side that I have more information about is that capital E and lowercase e. So I'm going to go ahead and say sine of capital E divided by lowercase e, where capital E is my unknown. Now for this problem, I don't need to cross multiply. I'm still more than welcome to, but in order to get capital E by itself, I can start by just multiplying both sides by e. And now I end up with e sine of capital D divided by lowercase d equals the sine of capital E. This is usually where I like to plug into my calculator to start with. So I'm going to go ahead and substitute in. We've got 10 sine of 55 degrees divided by 13 equals sine of E. Now, again, I want to caution you guys, please make sure that you're always writing down both sides of your equal sign. If you don't write down both sides of your equal sign, you end up getting close to making a mistake or just barreling through the problem and not realizing what's wrong. So the reason I said that now is because I found out that 0.630 is equal to the sine of E. And there's a lot of people that look at this and say, well, 0.630 is a really small angle. How can that be? And you're right, because our angle is not 0.630. The sine of our angle is that. So to get just the capital E by itself, you take the inverse sine of both sides, 630, and this will give you your angle of 39.059 degrees. So that right there is my capital E, 39.059 degrees. As I pointed out previously, you are more than welcome to use law of cosines to solve for little f, and then you can use any other method you'd like to solve for capital F. Since this video is primarily about law of sines, I'm going to go ahead and just use the 180 degrees idea to solve for capital F, and then I'll use law of sines to solve for lowercase f. So 180 degrees is equal to d plus e plus f, which means 180 degrees minus d minus e equals capital F, which means 55 degrees minus 39.059. I want to point out at this point, I'm going to use the full answer that they gave me. This is a slightly rounded number, so when I punch into my calculator, I'm going to be sure to use the full answer that that calculator gave me. So 180 minus 55 minus that big long answer that they gave us previously tells me that my angle is 85.941 degrees. So 85.941 degrees. And last but not least, I can use that law of sines to calculate. There's a lot of people that are, wrong color. A lot of people that try and use Pythagorean theorem at this point, and they say, oh, we've got two sides, so let's use Pythagorean theorem. But that only works for right triangles. Because this is a non-right triangle, I need to make sure I never use Pythagorean theorem, and I never use those trig ratios of SOHCAHTOA. So again, I pick a trig function, or sorry, a side angle pair, as I call it. Lowercase d is equal to sine of capital F divided by lowercase f. To get lowercase f by itself, I'm going to go ahead and cross multiply. F sine of d is equal to d sine of f. Divide both sides by the sine of d. d sine of f divided by the sine of d. Substitute on in 13 times the sine of, and again I'm going to use that big long number that the calculator spit out. I'm going to try and avoid using my rounded numbers if at all possible. Times the sine of 55 degrees. So punching it in, 13 times the sine of that big long number divided by the sine of 55 gives me a final answer that f is equal to 15.830. So final checks on here. Largest angle is 85.941. It is opposite the largest side. Smallest angle is 39.059, which is opposite the smallest side. And the middle side gets the middle angle. In a later video, we're actually going to discuss that this problem specifically, this one right here, the SSA triangle, we were given two sides and an angle, is a little bit more complicated than previously anticipated. This one, I chose one specifically to be nicer, but it is a bit potentially different. The last thing I need to point out about the law of sines is we did take the inverse sine at some point. So you need to be careful anytime you're taking an inverse sine. Because of those restrictions that the calculator puts on inverse or arc trig functions, anytime you take the inverse sine of something, you run the risk of taking the inverse sine of an angle that's greater than 90. And if you take the inverse sine of an angle that's greater than 90, then things can get messed up and you could run into an error. So be very, very careful anytime you use that inverse sine. You always want to solve for the smallest angle using law of sines, or at least the middle angle on there, or ideally use that law of cosines. Law of cosines will never mess you up when you hit that inverse. Law of sines might, so be very careful with that.